Hi, how you all doing? Hope you're safe and well, okay? Hope you're safe and well. Hope you're enjoying the mathematics course, okay? In this special video, I want to go through some examination style questions, okay? I say special video, of course all my videos are designed to be special because they're designed to be helpful, otherwise I wouldn't be doing them. But this particular one is where I look at some examination style questions because it's important, even at this early stage in your course, that you get to see what the examination questions look like, what the wording is, okay, how they're phrased, what your methods should be, and what the examiners are looking for, okay? So I'm hoping that you find this video quite useful for you. What I'm going to do is I'm going to write up the questions like I've done already on the board. Because I have to pre-prepare them, I'm going to have to fill them in separate slots and then just string them all together. So at the end of each question, you'll kind of see me fade out and then fade back in again. That's just to save myself time copying out the questions, okay? I'm sure you understand that. So the first question is ready to go. What I recommend you do is for each one, you just pause the video and have a go through it and then unpause it and see what the solution is, okay? So here's question one, bizarrely called question one, even though I put number 2 on it. It's just because the question I found it from the particular examination booklet was entitled question number 2. Anyway, I'm sure you'll get used to it. So this is express 9 to the power of 3x plus 1 in the form 3 to the power of y, given y in the form ax plus b, okay? So what you need to do is you need to think, how are you going to rewrite 9 to the power of something as 3 to the power of something? It's quite simple. What is the relationship between 9 and 3 in terms of indices? 9 is 3 squared, okay? So I'm just going to write that down. 9 is the same as 3 squared. So I can write that as 3 squared to the power of 3x plus 1. And that's your first step, okay? Next, using the rules of indices, you've got a to the power of m to the power of n is equal to a to the power of m multiplied by n. That means this is the same as 3 to the power of, and then 2 times that. So 6x plus 2. And then we're done, see? Because we've got it in form 3 to the power of something. And you'll notice that y is in that form. What the examiner's really after is you actually making sure that you make it clear that this is your value of y, okay? And the way you can do that is to write down y is equal to 6x plus 2, okay? That's it. That's the first one, okay? Okay, let's do the second question. Incidentally, why is the second question called question number 1? Well, it's just because I've taken these from actual examination papers, okay? On this particular year, this was question 1. So the first question I did just a few moments ago, that was question 2 in that particular year group, okay? That's just in case you want to go back and have a look at the exam papers and see where the questions actually came from, okay? I also think the number of the question tells you an idea of how easy it's supposed to be, because the questions are generally quite stepped, okay? Anyway, before I go through this, if you've not actually seen these questions before, maybe you pause the video as soon as you see them go up, okay? So basically this question is to simplify this, root 48, subtract 6 over root 3, and write in the form a root 3, where a is an integer. And then part 2 is to solve this equation, giving your answers a rational number. So, you know, I'll go through the solution now, but you can just pause the video, okay, if you've not had a chance to work it through. Right. Just some language in terms of the question, what it means, okay? So simplify this, okay? But then quite often they ask you to write your answer in a particular way, all right? The reason for that is because most of the time they don't want you to write it as a decimal, okay? They don't want you to just press the SD button in your calculator and write it down as a decimal. Why not? Because that's not accurate, okay? Maths is about precision, it's about accuracy, okay? Thoroughness, all right? All those things. And if we can write our answer in surd form here, that is much better than write it as a decimal form. Because surd form is exact, decimal form isn't. You've got to round it to 1 decimal place, 2 decimal places, or whatever, okay? And your calculator is limited as to how many decimal places it will give you. Remember, a surd is an irrational number, okay? And so is the decimal value. It does not exist as a finite set of digits, okay? So that's why most of the time in these sorts of questions they'll ask you to write down as in a particular way. Right, let's have a look at this. By the way, just a reminder, set of integers, so a belongs to a set of integers there. I'm just going to rub that off, okay, so I can provide some working. So the first thing I want to do is rewrite root 48, okay, which of course is root 16 multiplied by root 3, okay. And then this one here, if you want, just put some work in there, okay. rather than write down the whole question again, in the question space, just put your work in there. Multiply top and bottom by root 3. That's how to rationalise the denominator, of course. And so this ends up being 6 root 3 over 3. Okay? And then we can just simplify it a bit more. So that's 4 root 3, and 6 divided by 3 is 2. So it's 2 root 3. Absolutely lovely. That's what we're wanting, isn't it? We're wanting these two sides to be the same, because remember, I've got to write it in the form a root 3. Well, that number a is 2. Okay, because 4 subtract 2 is obviously 2, and so we've got 2 root 3. That's it. Okay, that's all that is. Okay. Then it's part 2. Solve this equation here. Give as a rational number. Okay. So what that means is, again, don't write it in decimal form. Leave your answer as a fraction. That's what it's kind of trying to tell you there. Right, with these, you've got to be able to spot what is the link between the 3 and the 81 in terms of indices, okay? Because it's a question about indices, isn't it? Well, I'm just going to leave the 3 there, okay? 6x minus 3. But then the 81, you can write as 3 to the power of something, okay? If you're not sure what it is, just put in your calculator some roots of 81. So do square root of 81, cube root of 81, fourth root of 81, and eventually you'll get there, to the number 3. And it's the fourth root of 81 is 3. So that means 81 is 3 to the power of 4. Or other way round, you can start with 3, think about what's 3 squared, 3 cubed, 3 to the power of 4. Just keep on going. You won't have to go too far, okay, in these sorts of questions before you get what your power is. And then what we've got is we've got 3 to the power of 6x minus 3. It's the same as 3 to the power of 4. So that means that the powers are equal. They're the same. Because 3 to the power of that equals 3 to the power of this. Those two bits must be the same. So you've got 6x minus 3 equals 4. That's rather a simple equation to solve, isn't it? So you've got 6x is equal to 7, and x is equal to 7 over 6. Remembering what it said in the question, leave it as a rational value. That is a rational value, 7 over 6. Okay. Next question coming up. Okay, this is question 3. So f of x is x squared, subtract 10x plus 23, and part 1, or part A, expressed in the form x plus a squared plus b. Alright, and then find the exact solutions to this equation, equals 0, find the roots, in other words. And part C, hence, using your answer to part B, in other words, find the largest solution to this, y minus 10, y to 0.5 plus 23 equals 0. Write your solution in the form, there we go again, you see, write it in a particular form. P plus Q root R, where P, Q, R integers. Again, you can just pause and work your way through that if you've not done so already, and then unpause and see what the solution is. Okay. Right, part A, so this is completing a square, isn't it? Okay, it's kind of nice, it kind of tells you how to do it really. X plus A squared plus B, it's kind of saying to you, look, it's got to look like this, X, and then something squared plus something else. Obviously, because of the negative 10, it's going to be subtracting there. Remember how the method, just divide the coefficient by 2, okay, half coefficient, get x minus 5 squared. So that gives you x squared, subtract 10x plus 25. If we subtract 2, that gives us plus 23. Okay, so that's the first bit done. Find the exact solutions to this equation here. So, like, just to save myself some space, okay, what I'm going to do is I'm going to just write down there equals 0, okay, and then we're going to solve this equation, okay. So the first thing to do is put the 2 on the other side, of course. Do you mind if I just rewrite it like that? Now, whatever you do, don't go back and do this in your actual solution, okay, so don't go back to part A and readjust that, because the answer I had up there, part A must stay, okay, you must have the x minus 5 squared subtract 2. Okay, I'm just doing this because I'm limited in board space. Okay, so in solving this equation, I've got x minus 5 squared is equal to 2. X minus 5 is equal to, do not forget, the positive or negative. Okay, root 2, and then put the 5 into that side. You've got x is equal to 5, and then plus or minus root 2. That's it. Those are those solutions. Okay. Hence, the original question didn't say hence, but I put it in because it's commonly used, okay? Hence means use what you've done previously to help you with the answer to the current question, okay? What it was actually written as was use part B, okay, which is a bit more obvious. Using this answer here, find the largest solution to this. Well, first of all, let's just think about what it means by the larger solution, okay? So going back to part B, you must think that the two solutions are 5 minus root 2 and 5 plus root 2. Well, clearly the larger one there is 5 plus root 2. Okay, so it's likely in the answer of this, we're going to have to use x equals, let's write it down, x equals 5 plus root 2, okay? Find the larger solution to this. Well, can you see how similar that equation is to that there? Okay. The only difference is, of course, that instead of x squared, you've got y, and instead of x, you've got y to the power 0.5. Well, quite simply, what that means is you've got y is the same as x squared. Okay. If you put y as x squared there, so you get x squared. Okay. And then obviously you've got y to the power of a half, the square root of that would be x, okay, because x is the square root of y, y to the power of a half, okay, and then plus 23. And when it says find a solution, you want to solve for y, don't you? You want to work out a value of y. So you want to find what y is, given that it is x squared and x equals this. So your solution then, okay, is going to be y is equal to this, 5 plus root 2 squared. That's what it's asking you to do. Okay, it's asking you to do that. Okay, and obviously if you took the smaller solution, you'd have 5 minus root 2. Okay, which is going to be a smaller number. So you're just going to expand the brackets here. Okay, so you're going to have 5 squared, which is 25. Okay, and then you're going to have 2 there because root 2 squared is 2, and then do not forget the 5 root 2 twice, so 10 root 2. Okay, so your answer there is 27 plus 10 root 2. I'm hoping you can see that all the way down there. Okay, and then just get back to this, write your answer in the form p plus q root r, okay, which it is. So 27 is p, q is 10, and r is 2. Okay, a lot of the times you can kind of ignore this bit. Okay, it's just there so that candidates don't go and write that as a decimal, as I said earlier. Okay, because that is your exact answer. Right, hoping that was helpful to you. Okay, so next up is another question 3, okay, just because these sorts of questions, they normally come fairly early on in the paper. Okay, so there you go, pause the video, have a go at it. So, simplify, root 50, subtract root 18, give your answer in the form a root 2, okay. Now, this is kind of nice because it gives you a really big clue, okay, it gives you a clue as to how to simplify these, okay. Because of the root 2, what that means is you can split that up into root 2 times something, and obviously that's going to be root 25, isn't it? Times root 2. And this here, root 2 times by root 9. So in these sorts of circumstances, you can use how they ask you to write your answer to try and help you, okay? And obviously then that's going to be 5 root 2, that's going to be 3 root 2, and then that's going to be just 2 root 2, because 5 subtract 3 is 2. That's it, okay? That's how you can use the wording of the question to help you get the answer. And then part B, hence, I think it said hence or otherwise, okay, so the or otherwise can be done, okay, but the hence is kind of giving you a hint, you can use this. Well, the thing to do is, when you're simplifying this, 12 root 3 over root 50 minus root 18, the first thing you want to do is just replace the root 50 minus root 18 with the 2 root 2, okay. That's the first thing you want to do, that's the hence bit. That's going to make it much easier to do, isn't it? Okay. Give your answer in this form. I'm just going to leave that there and go through the working. Okay. So if I just write this down over here. Now you've got 2 choices really. One, you can just rationalise the denominator straight away, or you can just simplify it a little bit. Notice the 12 divided by 2 is 6. Yeah. So you can do 6 root 3 over 2 if you wish. Oops, almost forgot the square root. And then when you rationalise the denominator, you're going to have to multiply top and bottom by root 2 like that. Okay. So on the top, you'd have 6, and that's going to be root 6, isn't it? 6 root 6. And on the bottom, you're going to have 2. So I'm leaving myself not much room here, but I'm just squeezing on the bottom. You're going to have 3 root 6. 6 divided by 2 being 3. So 3 root 6 is your final answer. Okay. Let's have a look at what it says here, because this is kind of interesting. Okay. You don't have to worry about it so much if this is your solution, okay? But let's just talk about what it says here. Give your answer in the form b root c, where b and c are integers. Well, I've done that. B is 3 and c is root 6. But what caught my eye is when it said this. Do not allow b is equal to 1. Because you might get the answer and think, what do they mean? Don't have b is equal to 1. Well, potentially you could have worked through this in a slightly different way, and you could have ended up with the answer root 54, which is the same. Okay, if you check it in your calculator, do square root of 54, it'll give you exactly the same answer. Okay, but in this case, you see, it will be in this form where c is 54 and b is 1. Okay, so what it's saying is they don't want a candidate to write it as the square root of an integer. They want the candidate to write it like this. Okay, this of course is the simplified surd anyway. Okay, and it's what your calculator will give you. Just do be aware of that. Okay, if the question had been written the other way round, okay, it could have been written like this: expressed in the form root c, where c is an integer. In which case, that would not be acceptable. Okay, that would not be acceptable. You'd have to write down this. How do you go from this to this? You just put the 3 back under the square root. If the 3 is under the square root, it becomes 9, because square root of 9 is 3. And you do 9 times 6, which is 54. Anyway, I just went off on a slight tangent on that, but I just thought it was a good opportunity. Okay. Hopefully you got to the answer, 3 root 6. Alright, this is question 5. Here it is. So take note of the question, work your way through it, pause the video, and then let's go. So what are you doing? Are you actually pausing the video, or are you just waiting for me? I don't know. You will get more out of it if you work through the thing, rather than just wait for me to actually do it. 'Cause it's easy watching someone do it, okay? Anyone can watch someone do it and think, yeah, it makes sense, okay? But if you can do it yourself, that's something else, okay? So do take my suggestion of working your way through it, okay? Anyway, not to force you, okay? I'm just grateful you're watching. Thanks for watching, okay? Hope they're helpful for you. Right, this, another one where you've got to complete the square, okay? So let's just do that. So express in the form x plus a squared plus b. So that's going to be x minus 4 squared, which gives us x squared, subtract 8x plus 16, and so another plus 3, don't we, to get plus 19. So that's done. It's quite easy. Sketch the graph. Oh, who doesn't love a good graph sketch, okay? Well, I love a good graph sketch. Sketch the graph y equals f of x. Okay, so basically sketch the graph of that. Okay, the whole point of asking you to write in this form is to make it easier to sketch. Okay? On the sketch, we're going to show the coordinates of the y-intercept, which is called point P, and the minimum point, which is called point Q. Okay, so I'm going to put my graph sketch down here. Okay, I've got some space to do that. So there we go, labeling the axes, x, y. So what does this look like? So of course the graph y equals x squared looks like this, passing through 0, 0 as its minimum point. This graph has been shifted 4 units towards the right, translated 4 right and 3 units upwards. So that means the minimum point is there. Okay. No, I've not finished drawing the graph. I'm just trying to indicate to you where the minimum point actually is. Okay, 4, 3. That's a suggestion for you. Okay, rather than draw the whole parabola. Okay. You could actually just put in where the minimum point is and then complete it, okay? So, another reason as to why the minimum point is there, a minimum value, okay, of y is found when that is 0, okay? Because x minus 4 squared, it's going to give you a squared value, and the lowest possible squared value is 0, okay? And so when you do 0 squared, you get 0, and then we add on 3, that's why the y coordinate is 3. And the x coordinate that will make this 0 is 4. Okay, so I'm hoping that makes sense to you. All right, so you've got 4, 3. So once you've put in the minimum point there, just continue the graph. Okay, just does that, and then just does that. Okay, there we go. Try and make it reasonably symmetrical, like this. Okay, I'm just going to label that as point Q. Okay, and point P needs to be there, the y-intercept. Well, of course, that's when x is 0. Okay, so you've got 16 squared plus 3, which is 9. Or look at the top one. 0, 0, 19. Okay. Sorry, did I just say 16 plus 3 is 9? Sorry if I did that, I apologise. Okay. Didn't mean to say that, of course. Right, 0, 19, and that's point P. Okay. So that's part B done. Okay. find the distance PQ, given your answer was a third. Okay. Right, so if you're not too sure, just draw a straight line to see what's going on. Okay, that's the distance PQ. Do you remember when you're in year 9 or 10 or something like that, where you had to work out distances between two coordinate pairs? Yeah, I'm sure you did. Okay, use Pythagoras Theorem, don't you? Okay, try and get it into your head, try and get into the mindset that a distance often uses Pythagoras Theorem, because if you've got any 2 points, like I'm going to give you another example, say between here and here, you can always join 2 points up with a straight line, okay, and then you can use the coordinates given to work out the change in x here and the change in y there, and of course that's a right angled triangle. You can always use Pythagoras Theorem, okay, so that's the method that we need to use here. We need to use Pythagoras Theorem. So what you can do is write down that PQ squared, and that, yes, that's how we write it, okay, because it's a length PQ and then PQ squared, written like that, is equal to, and then what's the change in horizontal going to be? So that is 0, that's 4, so that's 4 squared, and then what's the change in vertical going to be? That's 19, that's 3, so change in vertical is 16, so 4 squared plus 16 squared, isn't it? Okay, and then of course PQ is just going to be the square root of that, so I'm going to write it down like this, okay, square root of 4 squared plus 16 squared, okay. Back in the day, students had to do this question without a calculator, okay. Obviously you can just pick up your calculator and just write down your answer, and your calculator will give it to you as a simplified surd, okay. It kind of takes the fun out of doing things a little bit. So I'm just going to show you what you can do to do it without a calculator, okay. So I'm just going to rewrite that as the square root of 16 plus 16 squared, okay. 16 squared of course being 256, but then we do 256 plus 16, 272. It's not as easy a number to simplify, is it? Okay. I'm just taking that out because I've noticed that you've got a common factor there, 16. So what I'm going to do is I'm going to take that outside the bracket, okay, and I'm going to write it like this, 4 and then square root of 1 plus 16. Whoa, what happened there? Some of you are saying, how on earth did you go from this line to this line there? Okay, well, let me just show you. Up right here. So if I've got 16 plus 16 squared, I can rewrite that as 16 times 1 plus 16, can't I? A bit like algebra, expand the brackets. 16 times 1 plus 16 is 16 plus 16 squared, okay? And then when I do the square root of that, of course, I get square root of 16, which is 4. And then square root of 1 plus 16, okay, hence 4 root 17, okay. Check if you don't believe me, but that's what the calculator will give you. It will give you 4 root 17, okay. So I'm hoping there's one or two of you at least that might have preferred the non-calculator approach, okay. Sometimes you need to treat yourselves, you know, treat yourselves to not having to use a calculator, okay. All right, hope you enjoyed that. Okay, question 6. There we go. Pause, have a go, unpause, watch. Right, that done. So given that y equals 2 to the x, show that 2 to the 2x plus 1 minus 17, 2 to the x plus 8 equals 0. Okay. Some of you might be thinking, I don't recall doing these sorts of questions in chapters 1, 2 or 3 of the P1 book. Well, it's about rules of indices, okay, and you've got to be able to use your general knowledge of how maths works to use the rules to see how they fit in with this, okay. Show that that can be written in the form this, okay. Well, hopefully that's an obvious one, yeah, because y is 2 to the x, so it's just since that's not really a problem, is it? So I think we just put that in straight away. So 17y plus 8 equals 0. It's more of this term there, isn't it? Okay, that one there. What we can do with this? Well, what I'm going to do is I'm just going to rewrite it like this, okay? So that's the same as 2 multiplied by 2 to the power of 2x, and then this 17y plus 8 equals 0. Can you see how that works? You can see how the rules of indices fit in there, because the rules of indices state that when you've got like a to the power of m multiplied by a to the power of n, you just add the indices together, okay? And so 2 to the power of 1 times 2 to the power of 2x, you get 2 to the power of 2x plus 1. Okay, that's how that works. Okay? So that's that. So we've got the 2 there, you see, and then this bit, we're just going to write that as 2 to the power of x squared. Okay, that's because of this rule here. A to the power of m in brackets to the n is equal to a to the power of m multiplied by n. Okay, so you see how that works. 2 to the x squared is the same as 2 to the power of 2x. Okay, and then 2 to the power of x is just y. And so those are your steps. Okay, like I said, it's just a matter of rules of indices. Okay, in order to get your required result. So that's the first part done. Hence solve. Well, I'm hoping it's obvious. If it's not obvious, then you need to try and quickly get your head around this way of thinking. It should be obvious that you want to solve that. Okay, you want to solve that first of all. Okay, 2y squared minus 17y plus 8 equals 0, and then see what we do with it. Most of these factorise. Okay, so let's have a look. So that'd be 2y, I reckon, and yeah, subtract. And then y subtract because it's negative there, positive there, okay. And because of the 17, I'll go for 8 there because I reckon you can combine that. 16, 1, 17, yeah, that'll work, okay. And then let's just write down the two solutions. So you've got either y is equal to 1/2 from that bracket, or you've got y is equal to 8 from that bracket. And then we'll just see where to go from there, okay. When it says solve this, you need to work out what x is, find the values of x. So go back to this here. So y is 2 to the power of x. Okay. So what that means is you want to write down what this is as a power. Okay. So 1/2 is the same as 2 to the power of -1. Okay. So that means is that x in this case it must be -1. And then this one here, y as a power of 2. 8 is 2 to the power of what? It's 2 to the power of 3, 2 cubed. And so that means that x is equal to 3. That's all it is. Okay, that's all you need to do. If you need to check that, you just put in x equals 3 into this, check you get 0. Put x equals -1 into this and check that you get 0 again. Okay, hoping you found that helpful. Okay, 7th question then, simultaneous equations. Yes. Who doesn't love simultaneous equations, eh? Okay, bit of algebra, never hurt anybody in their lives, okay. Algebra features heavily in Star Wars, in case you haven't noticed, okay. Spaceships, your X-wing, Y-wing, A-wing, B-wing, okay. Letters that you noticed, okay. What was most important of those? The X-wing, the X-wing, the X being the most important letter in Star Wars. Why? Because the X-wing destroyed the Death Star. Yes, indeed, okay. Everyone loves a bit of algebra, even George Lucas, okay. How do we solve these simultaneous equations? Okay, well, the way to go is to rearrange the top one, isn't it? Okay, so you rearrange the top one, make it so it's y is equal to -4x subtract 1. Okay, and then just substitute it into there. Okay, so substitute in, you'll get -4x subtract 1 squared plus 5x squared plus 2x equals 0. Now you should realise, okay, even though you might not have thought about it, you should realise that that is the same as this, okay, because it's all negative, okay. All I'm going to do is I'm just going to rewrite that as -4x plus 1 like that. It's the same thing, isn't it? Okay, and when you square a negative value, it just becomes positive, okay. So when you expand the brackets there, just think of it as 4x plus 1 squared, okay. So you've got 16x squared, don't forget to do 4 squared, okay, as well as the x squared. And then you're going to have plus 8x plus 1, and then this here, plus 5x squared plus 2x is equal to 0. And then we'll just simplify it a bit more. So what's that going to be? 21x squared plus 8x plus 10x and then plus 1. Let's just see if I got that right. So 16, 5, yeah, and 8x, 2, yeah. Okay, done. And then work out that is. The vast majority of these will factorise, okay. Quite an easy one actually, isn't it? Because they're all positive terms, that's a 1, so it's going to have 1 at the end of both brackets, okay. 21, you've only got 21 and 1, or 7 and 3, okay. Because of the 7 and 3 and the 10, it's kind of obvious it's going to be 7 and 3. So 7x plus 1 and 3x plus 1, okay. If you don't believe me, just check. That's 21x squared, okay, 3x, 7x, 10x, 1 is 1, okay. So getting ready to work down the solutions, because remember you've got to work out y's as well. Okay, so you've got two values for x. Your x is equal to either negative 1 over 7, and you're going to have to find a corresponding value of y, or you've got x is equal to negative 1/3 from that bracket, and again you have to find a corresponding value of y. Okay, so negative 1/7, let's just go back to this to work out what the y value is going to be. I'll tell you what, because of the negative there, I'm going to make it so it was that again, just 'cause it's easier. So negative 4 times negative 1/7, so that's 4/7. And then subtract 1, okay? Yeah, I've got that right. So, yeah, 4/7 subtract 1, so that's going to be negative 3/7, okay? So that's your first pair of solutions there. And when x is negative 1/3, we're going to have negative 4/3, positive 4/3. So 4/3 and subtract 1, and that is equal to just 1/3, isn't it? And that's it. Okay, very quickly done. Very easy for number of marks it's worth. I think it's 6 for this question. Okay, so negative 1/3 and 1/3. Okay, don't forget to pair your answers like that. Okay, because then it's clear that that x value and that y value, they go together. And same with this as well. Okay, hope you enjoyed that. Okay, next question. Have we got it? So 20x squared equals 4kx minus 13kx squared plus 2. It's got no real roots. Okay, show that and then this here. So I've left a bit of space to be able to do the work in there. Well, no real roots means that b squared minus 4ac is going to be less than 0. Okay, hence the less than 0, that's going to be coming up. So this should correspond to b squared minus 4ac being less than 0. Okay, of course. You want to use the discriminant, meaning a quadratic, where you've got 0 on the right hand side, okay? So what I'm going to do is I'm going to just move these around. So I'm going to put that onto that side. So I'm going to have 13k plus 20, and that's the x squared term, okay? And then subtract 4kx, subtract 2 equals 0. See what I've done there? Just put that onto that side. All of these just on that side. So you need a quadratic equals 0. Okay, and then the b squared minus 4ac, whatever you do, make sure you write that somewhere. Okay, it's less than 0 because that shows the examiner you know what's going on, you know what you're looking for. Okay, then let's go ahead and do it. So b squared, so that is b there, negative 4k. So you're going to have negative 4k squared, subtract 4 times a, which is that, 13k plus 20, multiplied by c, which is that, negative 2. And that's got to be less than 0. So this is going to be 16k squared. Again, not forgetting to do the negative 4 squared as well to get 16. And then negative 4 times negative 2, well, that's the same as positive 8. Okay, so if you wanted to write another line of working where I just change that to positive 8, okay, and then just expand the brackets. I've just not put another line of working because I'm limited in space here. Okay, and then what's that going to be? So 8 times 13, 13, 26, 52, 104. K plus, and then 8 times 20, 160, less than 0. And we've just got to hope that all of these divide by 8 to give that. Okay, so divide that by 8 is 2, divide that by 8, of course, because I've just done 8 times 13. And so obviously divide by 8 again, you get back to 13, and then divide that by 8, yeah. So if you want, just put in the additional, because it's to show you that question, isn't it? What you're doing to get from there to there. And then it's done. That's done. Find the set of possible values for k. So this is solving the inequality bit. Usually these factorise. Okay. How many times do I say that? I've probably said it so many times. I'm usually like doing this and I'm like, usually these factorise. Okay. Well, they do. I just want to try and make the point, okay? Because factorising is cool. Okay, everyone likes factorising. So let's see how this is going to work. So 2k plus something, and then k plus something else. I'm thinking 5 and 4. Yeah, you thinking 5 and 4? Which way around? 5, 4? No. That's not, that could be right. It can't be there, can it? So it has to be like, I was saying it can't be there because otherwise if you had 2k plus 4, then that's the same as 2k plus 2, and you know we've got 2k and k as possible factors, okay? So that's how I've reasoned that it's got to be that way around, okay? So 8k plus 5k is 13k, and then plus 20, yeah, that's great. So that's less than 0. So critical values, okay, critical values, k is equal to negative 5 over 2 from that bracket, or k is equal to negative 4 from that bracket there, okay? Quick sketch of the graph, just about squeeze it in here, okay, with negative 4 there and negative 5 over 2, it's negative 2.5, isn't it, there, and it's a U-shaped parabola, so just put it in like that, okay, it doesn't have to be perfect, okay, and less than 0 means you're in between those two x values, so therefore smallest value less than k less than largest value, and that's it, negative 4 less than k less than negative 5 over 2, okay, hope you enjoyed that. Okay, this is the last question, took a little while to write down actually, but here it is. Let me read it out. The straight line of the equation y equals 3x minus 7 does not cross or touch the curve with the equation y equals 2px squared minus 6px plus 4p. Okay. Show that 4p squared minus 20p plus 9 is less than 0. Okay. Well, look, this is obviously some sort of quadratic curve. Okay, looks like this. Okay. Now, if it's a line that intersects 2 times, okay, it does that. If it's a line that just touches the graph once, it looks something like this. If it doesn't do any of those, it could look something like this. Okay, it's the third case. Remember, this is a discriminant type question, okay? So discriminant b squared minus 4ac is going to be greater than 0 in this case for the 2 intersections, okay? Discriminant will be equal to 0 when it's a tangent, it just touches, and it's going to be less than 0 in this case. So the whole wording of this question is phrased so that you have to recognise that you're looking for the discriminant, b squared minus 4ac, is going to be less than 0 for the solution between that straight line and that quadratic graph there. Okay, so that's what the whole question is about, and hence you'll see that this here will be the discriminant and it's less than 0. So that's what the question's about. Okay, and in solving this and trying to work out whether or not these two lines intersect, you will write down this, won't you? You'll write down 2px squared subtract 6px plus 4p is equal to 3x minus 7. That's what you do, isn't it, to solve when two lines intersect each other, okay? And you'll get your possible values of x if they do intersect, okay? And you'll find as an equation that's insoluble over real numbers if they don't intersect, okay? So that's what the question is all about. Maybe if you didn't quite fully grasp that, maybe if you didn't quite fully understand it from the beginning, you pause the video now and work your way through it. Okay, hopefully you've done that. Or you got it in the first place, in which case, hey, well done, well done. Let's get to work on this then. So get a quadratic equals 0, so we'll keep the 2px squared there, and what we'll do is we'll just put the 3x into that side, okay? So subtract 6p, and if we're subtracting another 3x, we'll make that subtract 6p plus 3x, because that obviously gives us the negative 6px, and subtract 3x, okay? And then we've got the plus 4p, and then plus 7 there, okay? So that's our quadratic equation, okay? Looks nasty, doesn't it? Okay, but just put that behind you, okay? Just think of that as your A term, that is your B, and that is your C, okay? So using b squared minus 4ac is less than 0. Make sure you make a note of it somewhere. I've already made a note of it there, so as far as the exams are concerned, that's that bit done. They kind of know what my method is going to be. So the b squared is going to be that, so 6p plus 3 squared, which is the same as negative 6p plus 3 squared. Think about it, because b squared negative value, you get a positive number, okay? So subtract 4 times a times c. So subtract 4 times that, so that's going to be 8p, and then times by c, which is 4p plus 7, and remember that's the discriminant, that's going to be less than 0 for when it does not cross or touch the curve, okay? and then we'll just expand the brackets here. 36p squared plus, that's 18 times by 2, it's 36p plus 9, and then here it's going to be subtract 32p squared subtract 56p less than 0, and I'm hoping we're going to get to that there. So simplify this a bit, so 36p subtract 32p, so that's 4p squared, which is great because it's that, and then 36 subtract 56 is negative 20, again it's great because it's that, so subtract 20p, and then we've got a 9 somewhere, yes, plus 9 is less than 0. So there we go. That was kind of a nice question, but challenging if you're doing these for the first time. Okay, so there we go, that's that. I'm going to rub the board off, of course, to make way for part B. Hopefully you just freeze the frame and print it off if you want, or just copy it out. Copying out is always best. Okay. So I can rub all this off now because I've got that bit there, and that's the important bit for solving the inequality, isn't it? Hence, find a set of possible values. Now the whole question has been set up so that if you can't do part A, you can still do part B, because you can think that's a slightly different sort of question. Part A is about trying to get to this. Part B is solving that. Okay, so you've still got the number of marks on offer for part B. You can still get 4 marks for part B, is what I'm saying, if you can't do part A. So this here, what am I going to say next? Usually they factorise. Sometime I'm going to come across one that doesn't factorise, okay, in these videos. Right. If that happens, I won't re-edit it, okay, because the temptation will be to stop the video and do it again, okay, but I won't, okay. Let's just see if that happens maybe one day. Maybe you'll have to watch every single one of my videos from now on, just to see if that happens. Okay. Right, so, yeah, now, a lot of the times they tend to be like 2p and 2p as opposed to 4p and 1. If it's not 2p and 2p, I'll try again, okay. And you've got negative there, positive there, so it's subtract, isn't it? Okay. So maybe 3 and 3, well, that's not going to work, is it? Because then that will be 2p minus 3 all squared, and it doesn't quite look like that. So 9 and 1, doesn't matter what order it is, does it really? Of course, 9 and 1, because it's both 2p. Let's just try that, shall we? So 4p squared, subtract 18p, subtract, so where was I? Yep, subtract 18p, subtract 2p, so subtract 20p, good, plus, yep, that's great. So critical values then is going to be p is equal to 9 over 2, that's 4.5, or 1/2, which is 0.5, okay. And it's less than 0, so quick sketch of the graph, here we go. So that will be a half, that will be 9 over 2, 4.5. You want less than 0, so that's between here and here, isn't it? So where the graph is less than 0. So that means you've got your smallest value, a half, is less than p, is less than your largest value, 9 over 2. Half less than p, less than 9 over 2. Okay, that's it. And we've come to the end of my set of questions, okay? I'm hoping you found them useful, hope you found it helpful, okay? Remember, even though it's just the first few chapters we've done on the Pure Mathematics 1 book, okay? A lot more chapters yet to come. It is a good idea, even at this early stage in the year, to practice as many exam paper questions as possible, okay? Because you get familiar with the wording, the style of questions, okay? So when you finish the entire book and you do a complete past paper, you'll be a lot more familiar with the wording of the questions, okay? I suggest that the more past paper questions you do, the better prepared you're going to be for your exams, okay? Right, have a good day. See you again soon.